Okay, transpose. This indicates transpose of this matrix. And all you're doing is switching the rows and the columns. Simple ideal. Okay? In notation, your notation for the general m by n matrix this. Okay? Again, I is your first index, J is your second index. And I stands for the row. So all across the first row, you got ones for I. And you're, actually, okay. And you've got m rows and n columns. And that's the way it comes out. Okay? Row 1, row 2, all the way up to row m. Column 1, column 2, all the way up to column m. Okay? So write out for me. What do you think that transpose would be? And just write the transpose. Don't copy down what I had. Just write what you think the transpose would be. Yep. Okay. Figure you'd do it right. Just give you a minute. Think it through. So you got A11, A12 down through A1M. And we've kind of abbreviated once we get used to it. Okay. So this is m by n, this is n by m. Okay? Okay, well, transpose is important. When you do your picture of the subspaces of two spaces under linear transformation, one of the spaces over here is the null space of the transpose. And this is a very important picture. Again, we're not going to go into much detail any more than we already have on that picture until somewhat later in the course. But one should be familiar with that picture and understand it. Okay? So remember, one of these is the row space and one of these is the null space. Okay. I think I said null space of the transpose. It's a row space of the transpose. What do you got to think about it? Okay. But anyhow, the transpose comes about over here. Okay. Now, one thing about the transpose, okay? When you transpose, you reverse the order of multiplication, okay?
Okay.
County, similar to the inverse. I keep going over to the inverse here. Just tell you kind of, this is in section 2. Toward the end of the section, you've got several rules for transpose, okay? This is the most non-intuitive one, but after you work with it a little bit, it becomes intuitive. You can also say things like, multiplication by C doesn't make any difference. You multiply all these by C, and multiply all these by C, this will still be the transpose of what you get from this, right? Okay, and other things. What's the transpose of A transpose? Well, can you write out the transpose of this?
That transpose back to A?
Yeah. So, you know, an obvious property that you can prove by writing out this general form of a matrix, okay? Because when you put the rows back in the columns, you're back where you started from, okay? Okay, so there's the idea of transpose. Just some, again, just laying out a few fairly simple ideas, okay?